Well, it's a real pleasure to be discussing with you today some of my thoughts on the current situation on the planet and where we need to go to. This picture really encapsulates one of the most, momentous moments really in photography, full stop, I think. Taken with a Hasselblad 500 EL by Bill Anders on the 24th of December 1968 from Apollo 8. He took this amazing view of our beautiful, beautiful planet with the surface of the moon in the foreground. And he said when he came back that we went to discover the moon and instead we discovered the Earth. And what an extraordinary planet it is. When we compare it with all the other planets in the solar system, you'd be drawn to this one right away as a visiting alien. Yet we have set about destroying this beautiful planet with incredible enthusiasm and verve, really since the Enlightenment period about 200 years ago. And since then, we have led to some terrible catastrophic damage. Soil erosion. Half the soil of the planet has been lost in the last 150 years because of the intensity of our agricultural processes, industrial agriculture. Salinisation. 25% of soils in China and in Australia have been completely salinised, i.e. the salt levels have built up from irrigation. When you water the areas like this, which are very sort of semi-arid, what happens is the water quickly evaporates and it leaves behind a tiny amount of salt, but that salt builds up, and once the salt gets to a certain level, the soil is ruined. You can't get it back. And this is having a devastating effect on agriculture. Eutrophication, fertilizers. We apply loads of these, and 80% of applied fertilizers are washed off the fields into water bodies, eventually end up in the oceans, causing dead zones and toxic poisonous algae, the red algae there, for example. Global biodiversity has collapsed as a result of habitat destruction and all of these other factors. And of course, we know about climate destabilization. Here we have the devastating effects of climate becoming destabilized, and we've been looking at that at COP26 recently. Malthus's horsemen of the apocalypse were highlighted in the late 1700s. They were named as famine, disease, and war, the things that would keep the population under control. In our efforts to defeat these and to bring through a better well-being for humanity, we have instead unleashed three modern horsemen of the apocalypse: climate destabilization, pollution, and diversity collapse. And the result of these is famine, disease, and war. There's a certain irony in this, and the solutions we find have led to the same problems that we were addressing in the first place. It was James Hutton in about 1797, right at the end of his life, who summed up his thoughts, this great Scottish geologist, of course, saying, "I consider the Earth to be a superorganism and that its proper study should be by physiology." And this is a really incredible statement. And we need to look into what this superorganism actually looks like, what we nowadays call the Earth system. We want to understand this because ultimately, if we are dwelling within a superorganism, then we need to understand how that organism works. And to do this, we need to use something called systems theory. The first important characteristic of any complex system is that they are non-linear. It doesn't just go from the start through a number of stations like a train to the finish. Rather, it is very, very different than that. We have lots of interactions between every component in the system, including ourselves, but the system itself will alter the conditions and alter the success of each of those components within it. And this will be a rapid co-occurring, simultaneous multitude of transmissions between all of these components. And this will lead to tipping points eventually, where a system may change radically in a very short space of time because the overall configuration has altered in such a way that it becomes reborn in a very different way. We see this in ecotones, for instance, when we come to the edge of one particular kind of habitat and we switch to another very, very rapidly. And this is because the conditions haven't changed that much, but it doesn't take much to completely change the whole thing. Complex systems are emergent. It's not a matter of 1 + 1 = 2. That doesn't happen because it is a combination of all sorts of complex interactions. It's not Legoland. You don't build it like with blocks of Lego. It doesn't work like that at all. It's complex interactions of the parts that give rise to properties that only belong to the whole. And that's the definition of emergence. And there's no place for biomimicry, for taking a little bit of the way nature does something and plugging it into our human kind of way of doing stuff. It doesn't work like that. That this is a complex system, not some kind of, as I say, a Lego model. Examples of emergent properties, well, culture, for instance, in Haight-Ashbury here, and we see the King's Road with Centre for Punk in London. Other emergent properties, we think of your brain made up of lots and lots of these neurons, yet we can imagine incredible things far beyond what we can actually see. Think of dreams as well, like woken up totally terrified with a nightmare or in shock at a completely imagined reality. Let me turn now to the third and maybe the most important aspect of a system, and that is they are suboptimal at each component's level. Let's meet Susie the squirrel here. Susie the squirrel had her life changed dramatically when she was walking back from the woodlands and noticed the squirrel advertiser being advertised outside her local shop. It said, "Are you a squirrel who forgets where you hid your nuts? You need the Nut app. Compatible with all handheld devices, latest technology, finds 99% of your nut stashes, plus some that you didn't even bury." She couldn't believe this. She quickly downloaded it onto her device, and now she could find all the nuts she wanted to. And this was brilliant. The population began to rise because the little offspring would get fed more nuts. But then some problems started to arise because what squirrels do is in the spring they eat bird eggs to feed to their young to increase the protein. Unfortunately, because there's so many squirrels now, they managed to eat an awful lot more of these eggs, and the bird population collapsed. As a result, the insect pests of the forest increased and the forest began to die. And sooner or later, there would be no more nuts available for the squirrels. What a disaster. Now you might think, what a stupid thing to do. I mean, come on, optimizing for your nut gathering at the cost of the whole ecology? Well, that's exactly what we do as humans. Suboptimality at any given level is a sign of a working system. We need to be suboptimal in order for the whole system to work. Optimization for any single level is disastrous for the system. And this is where we have gone wrong. This optimizing, efficiency, all of these things. We've even made up the term eco-efficiency. It doesn't exist in nature. There is no eco-efficiency. Nature is very wasteful to allow the entire system to work. There are trade-offs everywhere, and we need to realign ourselves in this in order to fully have any chance of surviving. And then there's real-time feedback. This is what we call wiretapping. Systems are dynamic. This means there's constant feedback, as we saw with the non-linearity between all of the different components, and constant change. Things are being affected. We need large ears. We need to listen to all of the signs and indications that the greater system is letting us hear about. The fifth and final main characteristic of complex systems is self-organization. Complex systems self-organize and repair through emergence, but rarely back to what they were. And this can lead to a complete regime shift. And this is probably the most frightening possibility for us on the planet. That it'll shift in such a way that we won't have any space to actually exist anymore, certainly at the local level. What we need to understand is the Earth system is king and queen. It's everything. It's the ruling elite. And we have to fit into it. Our economics and our society and you and me have to fit into it if we want to survive. But the current economic model treats it merely as a source and a sink, somewhere to dump the rubbish, somewhere to get the materials that we need. The Earth system is sidelined here. Economics is ruling, and the unit of well-being is defined as the wealth, health, education, happiness, status, and plenty that the society has at the cost of the Earth system. My GDP is greater than yours, the great mantra of nationalism in terms of economics. Yet the GDP doesn't include the damage to the planet, and therefore most of the countries with high GDP actually have terrible, terrible deficits in terms of the overall costs of their economies. But economics has become king, and it's all about the economy, stupid. And the cost on society and the Earth system has been devastating. Zero-hour contracts, inequality, debt, environmental devastation, social dislocation, the rise of individualism. This statement that I'm all right, Jack. As long as I'm okay, it doesn't really matter about anybody else. And we've lost the entire essence of what it is to be human, actually. So where do we go from here, and how do we untangle these issues? We can ask, what can technology offer in the journey towards a sustainable future? And is human intelligence the best template for artificial intelligence? I've discussed all of this in my recent book, Artificial Intelligence and the Environmental Crises. And if you want to have a read of that, I think you'll find it really, really relevant to this whole debate. But let me summarize a little bit of that in the next few slides. First of all, let's define intelligence. Legg and Hunter looked at about 70 different definitions of intelligence and summarized these as the ability to achieve goals in a wide range of environments. Westerhoff et al. Put it this way: if we were to leave terms such as human and brain out of the defining features of intelligence, all forms of life, from microbes to humans, exhibit some or all characteristics consistent with intelligence. Given their integration within the Earth system and the close relationship between animals and the rest of the planet, Wilson suggests that we should create AI by modeling animal intelligence as the focus. The feeling is that this is a much more sort of connected intelligence in terms of being one with your environment, and therefore is superior to humanity's intelligence, which has separated us from the environment. Swarm intelligence is something that's found throughout the animal kingdom, and it's defined as the collective behavior of a group of entities. It was the Marquis of Condorcet, great French revolutionary, who came up with this idea and said that a larger group was more likely to come to the correct decision than a smaller group. It goes very much against individualism. Here we've got the sort of 4 examples of the ways that organisms interact with each other. An individualistic sort of neoliberal model of the Western world, it's everyone for themselves. Centralized model, information is fed into a central point and then a decision is made. In a leadership model, the leader themselves comes up with a solution and then disperses it to everybody else without any sort of feedback. And finally, swarm intelligence, everything is interacting with everything else. And then from that emerges the right thing to do. And so it's quite a different way of doing things as such. Intelligence in plants is not based in a brain, as we've already mentioned. It's based across all of the growth tips of the plant, and there can be millions of these. A single winter rye plant has 14 million root tips, and each of these root tips is exploring a slightly different world. In many ways, this resembles a small version of the Internet of Things. It's feeding back information and signals to the plant as a whole, which then can impact on the plant's decision making. And indeed, what was discovered much later, maybe as late as the 1980s, was that different plant species are connected by certain types of fungi, the ectomycorrhizal fungi. And these fungi link up to the roots of these different plants, and they allow the exchange of information and carbon and so forth across a community of plants. This interconnectivity across different species
gives a community swarm effect where everything's informing everything else. So we see this dispersed intelligence really spreading across an entire stand of plants. We have forests with all the different plants in it. What they also do is, if you're not part of this fungal network, then you've got very little chance of surviving in a setup like this. So it's almost like a secret handshake under the table. Because if you've got that going on, if you're part of the club, then you will benefit from it, whereas species that aren't part of the club won't benefit. We see community memory and data sharing among bacteria quite uniquely at the level of the DNA. Bits of DNA from bacteria can be sliced and then formed into little circles called plasmids, and then these can leave the cell and can be absorbed by other bacteria, who then can take that DNA and put it into their own DNA. This is really, really, really clever, because it means if one bacterium solves the problem of an antibiotic attacking it and killing it, then that can quickly spread to lots of other bacteria. And it spreads to different species of bacteria, not just within the one. And bits of DNA can actually be swapped to completely different species, which is quite extraordinary as well, including plants and animals, amazingly. At the heart of all of this intelligence lies feedback and communication. The bacteria are critically aware of the storytelling that's going on around them. And this storytelling is really interesting because in many of our ancient civilizations, storytelling has played and does play a very significant role. I remember being in Marrakesh in the great market there, and this is maybe about 20 years ago, and seeing this storyteller come in from the Atlas Mountains. And he stood up, everyone else kneeled down around him, and he started to relate these stories. And this tradition goes back for our entire history, really. And this storytelling is central to bacterial intelligence. We mustn't sort of underestimate the importance of stories. So we've seen plant, microbial, and animal intelligence. This all comes together in a much greater package called ecosystem intelligence. So why is ecosystem intelligence key to understanding everything, to understanding the Earth system? All other levels of intelligence work within the ecosystem and are governed by it. Animals, plants, and microbes are expressing the greater connected intelligence of the Earth system. Only within this greater church can any of it be understood. The why questions are resolved within the greater system, just like the shadows on the cave wall that Plato talked about. And these shadows represented much more complex things and were merely the final visual outcomes of a hugely complex reality. And when we compare ecosystem intelligence to human Western intelligence, upon which artificial intelligence is based, we see some stark differences. Ecosystem intelligence is non-linear, whereas human intelligence is linear. Ecosystem intelligence is emergent, whereas human intelligence is reductionist. Ecosystem intelligence is suboptimal, whereas human intelligence is optimized for humans. Ecosystem intelligence relies on real-time feedback, whereas human intelligence tends to sort itself out into silos with a silo mentality coming from this reductionist approach. And finally, ecosystem intelligence is based on self-organization from within, whereas human intelligence is a Lego brick approach, where we think we can build one piece at a time to achieve something much more complicated. But that just cannot happen, because we need all of these 5 aspects of ecosystem intelligence in order to fully integrate within that and to have a significant chance of survival. We can get a much deeper understanding of the Earth system and our role within it if we look at Thomas Berry's notion of the Great Transition, which he called the Ecozoic. And he wrote, from the period when humans were a disruptive force on the planet Earth to the period when humans become present to the planet in a manner that is mutually enhancing. And that's where we need to go. So here we have us playing a role, a mutually enhancing role, where our participation within the Earth system not only benefits us, but we also benefit the Earth system. And this is how the rest of nature really works.
The flaw in sustainability theory at present, I would say, is that we're trying to maintain the status quo, trying to make all this green energy to replace the black energy. We're trying to, not reduce the energy particularly, but just replace it with something that makes less carbon. The energy itself is part of the problem. The mantra must be reduce, 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 rather than anything else. And our activities must not only not damage the Earth system further, but they must strengthen the Earth system and allow it to rebuild. We need to re-envisage the circular economy as the embedded economy, the economy as servant to society and the environment, leaving no one behind. In 2017, myself and a couple of co-workers wrote an economic model wherein planning, resourcing, procurement, production and reprocessing are designed and managed as both process and output to maximise ecosystem functioning and human well-being. That has to be the priority. Bioparticipation, not biomimicry and Legoland is what's needed. We must step out of the big top of human-centered thinking and step into a meaningful integration through the relational self. And so we see true circularity here with community, environment and individuals working together. The economy is only serving this, oiling the wheels more than anything. So I'd like to finish with just the Prime Directive. A new Prime Directive. It prohibits humans and their economic activities from interfering in the normal development of the Earth system. Let's move from ecocide to the ecozoic, participating in a mutually enhancing relationship.
Thank you so much for your attention. I hope you've enjoyed this and got something from it. We're going to return now for some discussion.